It is my pleasure to introduce you to our first excerpt presenter in today's EcoCast, and you can see that we are starting things out strong here. Please welcome from the Scale Computing team, David Demlow, Vice President of Product Strategy. David, thank you for being here to kick us off on the EcoCast. I know you have some great stuff planned for the audience today, so I'll let you present and then I'll be back on for Q&A. Take it away, David. The floor is yours.
All right, awesome. Yeah, thanks for having me. I'm excited to be here. I want to talk about and kind of introduce the concept of building an application platform that is designed to support all types of workloads. Virtualized, containerized, and also in all sorts of different locations. Obviously spanning potentially public cloud to large data centers. And out even across the edge, as we're seeing a lot of the newer applications, things around AI, ML often drive further distribution of processing to support those kinds of applications. A quick little bit of background on Scale Computing. We were founded in 2008. We've been in this marketplace for a very long time. We launched our first hyperconvergence product back in 2012. And we were one of the first companies to really simplify managing on-premises data centers, combining storage, compute, virtualization, management into an appliance and a scale-out clustered appliance that was designed to, at that point, really focus on managing highly available virtual machines, but since has extended to supporting all types of applications, containers, Kubernetes, AI, ML, all the different types of things that you need to support, but really focusing on a couple of key things that are important, maximizing uptime. So being able to cluster commodity systems together easily, manage these systems as a single operational unit, improve operational efficiency. So again, let application teams and IT teams focus more on the applications and supporting and patching and updating and securing those applications versus carrying and feeding for hardware infrastructure, and ultimately reducing overall cost and providing that infrastructure. So to kind of set a groundwork, as I mentioned, our business really from day one, we've intended to focus across a wide range of infrastructure. And we have customers that utilize Scale Computing's platform product as their corporate centralized IT infrastructure, all the way out to a large recent focus, particularly on solving problems that extend out to the edge. So envision retail stores that have tens or hundreds or thousands of locations, or ocean-going vessels that have critical applications that they need to run without on-premises IT people, that need resiliency, that have intermittent connectivity. All the way from those kinds of use cases out to, again, that core centralized data center are areas that we are focusing on providing a platform for to deliver applications of any type. So particularly when you look at these edge environments, but really kind of any on-premises, you can run into various degrees of this. As I mentioned, you can have the issue of very limited or in many cases no IT staff. So you need infrastructure support that is able to run, basically care for itself wherever possible, maintain the availability and security of those applications. In a lot of these use cases, you may have physical constraints, size, power, cooling, things like that. So supporting a wide range of infrastructure deployment options becomes very critical to support and provide that single platform across different types of environments. You have to deal with connectivity outages. So the concept in these distributed environments of having one central brain that controls everything just doesn't work. So we've designed our systems to run autonomously, without internet connectivity being a constant requirement. And then, one of the things that application teams and IT organizations and business units have become accustomed to with public cloud is the ability to quickly deploy new applications to deal with unpredictable demands. So you need to have, when considering this, kind of global application infrastructure, a design for how you can scale up your applications, how you can rapidly respond to new business needs and quickly deploy new applications, how you can quickly respond to security threats and make sure that you're securing and updating and patching these environments. So Scale Computing, our overall product solution is called SE Platform, or Scale Computing Platform. And it involves a number of key pieces. We'll talk a little bit more about it. But one of the key pieces is our HyperCore software system. So this is our hyperconvergent software that unifies provides centralized resilient storage, compute resources, provides hypervisor capability to run VMs and other workloads, has integrated services like failover, like offsite disaster recovery, remote replication, all packaged and all managed in a really easy to manage and update solution that can run all of your applications. And we'll dig into some of the unique aspects and management concerns about different classes of applications. The other key piece that we want to highlight here is Scale Computing Fleet Manager. And this is the cloud-based software as a service solution that is designed to let you centrally manage, monitor, and control a potentially large fleet of these distributed hypercore systems to let you put the computing wherever it is you need for those specific applications. And again, here we're talking about things that may be, centrally managed in a few larger corporate-owned data centers, maybe some cloud-based resources, maybe 10,000 retail stores that all need some on-premises computing as well. So we'll talk a little bit about that. So, let's kind of rewind on legacy applications and systems. Traditional virtualization addresses many of those challenges. It lets you consolidate multiple applications into shared resources, have fewer physical things to manage, to secure, to patch, to update, to lifecycle. And then generally as a result of that, what we generally see is customers that are, consolidating what, maybe 10 physical servers, just as an example, virtualizing those, centralizing them onto a highly managed, highly resilient platform for basically for free, getting that built-in resiliency where they have, high availability, failover, application independent backup and disaster recovery, greatly increased resilience just by the nature of consolidating those onto a much more solid platform. The ability to quickly scale up applications. I need more RAM for this new deployment. I need multiple VMs and behind my load balancer. Those are obviously things that can be accomplished very easily on a virtualized infrastructure. And then even the ability to scale out that infrastructure as your needs grow. We've since day one of our product really emphasized supporting the ability to mix and match different kinds of resources. So say, for example, coming down the line, you have a new application that, just requires tons of storage. You can add storage heavy nodes to an existing system and expand that way. If you need, GPU resources, you can add new resources to support, your GPU driven AI ML workloads, things like that, but still maintain that common platform management, that common platform monitoring, which is really key, and still maintain standardized deployment of not just the physical infrastructure, but of your applications. So we, provide important tools in terms of things like supporting infrastructure as code, where you can define your entire enterprise from the infrastructure down to specific applications and revision those using infrastructure as code tools. Automated deployment from the physical infrastructure itself. So we offer zero-touch provisioning, where you can, as soon as a system is ordered, even before it's been shipped out to a particular site, you can pre-configure that in our cloud-based fleet manager portal, so that when it shows up on site, anybody that can basically rack it or plug in power and Ethernet cable can turn on that system, have it phone home, and be automatically deployed, reducing complexity, reducing errors, for human deployment, and very quickly deploying, getting your applications up to a running state, and then also achieving hardware independence. Again, I talked about the ability to kind of mix and match those resources. Containerized applications, and cloud native is, kind of a broad term, really were a tremendous benefit in terms of, letting applications developers rapidly deploy, update, test applications, push out to clouds, get resiliency across multiple cloud regions. But they introduce some new challenges if you are especially talking about the edge and distributing it out to a large number of edge locations. Just the agility that you get is compounded when now I need to maybe deploy and revision an application across 10,000 sites as opposed to 3 cloud regions or things like that. But the advancements that they get are undeniable. We definitely see them being rapidly deployed out to the edge. But from the developer standpoint, there were maybe some assumptions about the infrastructure that don't always hold true. It's at least on the IT team to make sure that they're considering these and providing these. So for example, resiliency is often assumed. I mean, in a public cloud, you take certain guarantees as just truth that are clearly different in a lot of these edge environments. Scale up, scale out is often just considered table stakes. So it's important to know, how can I rapidly deploy, scale out my applications, scale out my infrastructure. And obviously in the cloud or on the edge, it's not as easy as in the cloud of just, well, let me spin up these dynamic resources. It takes a little bit of planning, but it does take infrastructure that allows, that infrastructure to be basically reconstructed, remorphed, expanded as it's needed. Needs to be API and software driven. Again, infrastructure is code, and you need to design for it to be dynamically changing, with the end result being that for the application developers, the business units, it's much like the cloud, where nobody cares about the physical hardware that's sitting in a AWS or Azure data center. They care about the interfaces and the services, and that's a key thing when you're kind of looking at your overall corporate application delivery platform to keep in mind. And we help customers provide that same kind of infrastructure visibility to their application teams and business units. So this is, again, just another view of what it looks like. So kind of looking at it from the aspects of a couple of sites. Generally, we're deployed in a resilient cluster. That's not required. It can be a single node for applications that don't need that level of physical redundancy immediately. But here you see a 3-node cluster, which is a fully resilient configuration, running side by side, containerized applications. Maybe it's computer vision, AI applications, legacy virtual machines doing various types of workloads. We've designed this to basically look at two different key personas or users of the system. So one is whatever the IT team, whoever's been responsible for care and feeding for that infrastructure, providing them that fleet manager control plane where they get monitoring, they can set policy, they can do centralized orchestration, they can work with existing tools like Ansible. We've invested quite a bit in making sure that our entire platform ecosystem is very automatable, desired state configuration through Ansible automation platform in particular, but we have APIs and integrations with other types of tools. So, that's kind of the infrastructure manager view of the world. And then from the application teams, making sure that they have their interfaces the way they're used to dealing with things. So whether it's, using GitOps and checking their artifacts in after a CI/CD pipeline into a container registry in a Git repo, we have the interfaces and the integration to be able to then deploy those applications as frequently as needed out to multiple edge-based systems, as well as we do find customers often have very opinionated platforms that they're using. Let's say Azure Arc, AKS, or Google Anthos, or AWS. All of those tools have extensions that can be distributed and run out to the edge, but have the applications controlled via those cloud control planes. So we've worked to make sure that our system, while we're managing that physical fleet of infrastructure, can tie into those existing developer tools, pipelines, and so on and so forth. And I think when you look at it, those are both kind of important things to look at, is maintaining that application teams and developers can keep using the tools that they're comfortable with and familiar with. The IT and operations teams, or the platform engineering teams, if you're going to that level of term, they have the tools that they need that's appropriate them to be that internal service provider to their application teams and business units. And again, what makes this all possible is something that we've been doing now for over 10 years, is this infrastructure that cares for itself. And to throw out the AI term, since I'm again obligated to do that, one of the key things we don't have really time to get into here is that our whole hypercore system was built on from day one an AI ops type of infrastructure that was designed to say, we're going to have a bunch of workloads we need to provide. We're going to have a bunch of resources to do computing and storage. Things are going to fail. Things are going to come and go. And design the system that can locally and autonomously make those changes, optimize the system with the resources that it has available to keep the applications up and running. And so that kind of self-healing, self-managing infrastructure is really, really key to being able to support these operational sites. And the end result, if this is all done well and offered to the business unit, is that you can provide cloud-like management for any locations, whether it's a distributed edge deployment, multiple data centers, hybrid cloud. You can maintain, provide your teams and your application developers with the availability, the scalability that they need, the automation that's required, both on the infrastructure management side and on the application deployment side, still maintain ease of use, very cost effective, and in the end, have a very business driven, business centric solution for delivering and supporting your applications wherever they need to be run. And with that, I wanted to thank everyone for your time, and I think we'll have some time for questions.
All right. Thank you, David, for that awesome presentation. I do want to point out that I've put up a poll question for you all in the audience. We'd love to get your feedback on any additional resources that you'd like to explore from Scale Computing. Your feedback here is so valuable, so please do take a moment to answer that poll. And with that, yes, we've got quite a number of questions that have come through for you, Dave. So let's dive into it. First, can you provide examples of how native container support simplifies the deployment and management of containerized services?
Yeah, I mean, containers are, without getting too deep into the nuts and bolts, are amazing in that they both allow and force application development teams to isolate their application code from the data from the infrastructure. And so, one of the huge benefits of that is, automation that is just impossible or, impractical with very monolithic application stacks become possible and easy, and so things like, deploying new containers on an hourly basis is not an insane thing to do. Patching, the runtime, with containers, there's still an operating system. There's still the need for patching, being able to frequently update those without impacting your applications or your data become more possible. So the ability to, dynamically change all those things, all those pieces within the application stack independently and do it in a code-driven, automated, repeatable way is really, kind of the key benefit there.
Amazing. I love how it's so quick, it's so adaptable, it's so intuitive. So I've got another question for you. This one's from Phil. What are the key advantages of shared resource pools in the context of edge applications?
Well, I mean, I do think that's generally where, higher consolidation. So, specifically when you think about very large, deployment environments, most of them, take, for example, retailers. We talk to retailers all day, and a lot of them, everyone, if it's a grocery store, they compare IT infrastructure costs to how much bananas, cost. And so, being able to very efficiently utilize those resources cost efficiently is very key. Just simplifying the management. I mean, one of the things we'll go into, I mentioned, the example of walking into, and this is, very typical, a manufacturing site or a retail store, and there's 10 different boxes, and you start asking, well, what does this box do? What does this box do? When was it deployed? When's the last time you've looked at the BIOS on that hardware? When's the last time you've updated the operating system and the application? Consolidating all that, and I guess, this is where it is platform specific. With the Scale Computing platform, we handle all that for you. So our system updates, when we have new capability, things like that, we're also updating the BIOS on the hardware that we support. We're updating our operating system stack, our virtualization stack, our container runtime, our management interfaces, our API. And by the way, it's all one single click, and on a multi-node cluster, it's with zero downtime. It's literally a rolling upgrade across the whole system that can be scheduled. It can be, initiated via automation, but, those kinds of things are one of the advantages of centralizing and consolidating multiple applications onto a resilient platform like that.
That's great. And, I think you've touched a lot about how easy it is to use Scale software, how easy it is to manage. And so you might have touched a little bit on this already. But we've got a question about can you share some insights into the developer-centric features that enhance the overall experience of the deploying, updating, and managing of your containerized services?
Yeah, I think I kind of covered it, but I mean, our goal is to, in general, let developers use tools that they're already used to. So however they're, developing, testing, their applications. We want to make sure we can just plug into their existing pipelines and workflows. But secondarily, there may be some new capabilities that we can provide that wouldn't be inherent on just any other platform. And things that I'm thinking of there would be things like cloning that and template management that we can do to help them quickly do testing and roll back, do canary deployments on a subset of sites, get results back, stage deployments, things like that. Those are things that are kind of just inherently built into our platform as capabilities that don't necessarily apply if it's a single big data center, don't necessarily always apply in a cloud-based environment. So there's some things like that I think are new capabilities for developers to explore. In general, I guess just for some applications, making it some applications we've seen historically get forced into centralized cloud-based deployment, even when they're not the optimal experience or the optimal cost, or now you're forced to deal with latency of going from some location to a central cloud, doing some processing, getting things back. So the freedom to, without kind of having to care about where things are running, design your application for the best experience, and then let the platform deliver those pieces in the right places. I think that's probably ultimately the biggest benefit for the developers and the application, the organizations that use those applications.
That's awesome. Okay, I think we have time just for maybe one or two more questions here, but you've been great shedding so much light on everything. The last one, again, I think you brought a little bit of this up in the presentation, but maybe just shedding any additional light. The question here is, do you have some examples of the tools like Cloud Init and Ansible, which you mentioned, used for deploying templates and maintaining consistency in application stack deployment?
We have all sorts of example. For example, I demo these all the times. I have some public Git repos that even have example fictitious organizations where you can kind of see how it would all plug together. You mentioned several of the integration and automation points that we provide. Our local REST API, our fleet level REST API, and a very robust Ansible collections actually certified with Red Hat for support there. So all the pieces are there to do, orchestration really from day zero, deploying the cluster, deploying the applications, updating the cluster, updating the applications, kind of full life cycle is all there. And we've got examples, blueprints to get you going. We have services that can set all that up for you if you want that to be taken care of for you as well.
Awesome. Okay, David, I think before we wrap things up, we've one last question for you. Because you have so many resources and you've mentioned, being able to do these demos and that, if someone out there wants to learn more about scale computing and get started right away, how would they do that?
I suggest going to the website. We can, schedule an in-person demo. I've got, plenty of resources up there as well. But that would be the place to start. And we can do a sizing estimate of your current environment, your projects coming up, and make recommendations of where and how we can best help.